So we've got two more methods that we're going to look at from section 3.1, and these are two methods that I'm really hoping look familiar to you. I know with the last lesson, going by a graph or going by a table may not have been familiar, but it was actually meant as more of a warm-up than anything else. Plus we got to use our calculators, kind of play around with a couple of the different features on there. But today we're doing the substitution method and the elimination method, which, like I said, I think should probably be familiar to you. So we're going to write down some steps first, and then we've got some examples. We were going to walk through how to follow those steps. So, step 1, solve one equation for one of the variables. So I think what I'll do is, as we're writing these steps down, I want to jump back and forth between the example problem and the steps, and that way you can really see the steps at work. So if we jump to example 4, we've got two different lines here. They're both in standard form. We've got this first one and the second one. One thing I want to emphasize that I keep seeing you guys do on quizzes and tests, I know you're really familiar with slope intercept form, y equals mx plus b, but a lot of you keep making mistakes trying to turn an equation from standard form into slope intercept form. We need to get familiar with standard form as is. So we need to leave them like this for the most part, unless of course you've got a command like this to solve one equation for one of the variables. So with these, you do have the option. You can solve the first equation for x or for y. You can solve the second equation for x or for y. What I want you to keep an eye out for in this first step is one of the equations that has a variable by itself. If we look at this first equation, for instance, say I wanted to get the x by itself, I would have to move the 3y over, and I'd have to divide by the 5 that's in front of the x. Same thing with solving for this y, same thing for solving for this x, but this y right here is already by itself, so all I would have to do is move the 2x over, and I wouldn't have to divide, because the y would already be by itself. So for step 1, it's not that you don't have options, but usually there's one option that will make things easier for you than others. So we're going to take this equation, and we're going to solve it for y. So 2x plus y equals 7. So to get this y by itself, I am going to subtract 2x from both sides. So here's where I'm at. So I now have the y by itself on the left-hand side of the equation, and then here I can just write 7 minus 2x. There's no need to write it in the right order. Like I know with mx plus b, you're used to putting the negative 2x before the 7, but there's no need in the substitution method. So we write it like that, and notice the 7 and the 2x, they don't have any like terms, so I can't combine them. Step 2, what we're going to do is substitute that expression into the other equation. So substitute the resulting expression and by the resulting expression, I mean what I just got right here for y. So substitute the resulting expression into the other equation. And then solve the equation. So once we do substitution, we're only going to be dealing with one variable temporarily. So when it said the other equation, that means we're going into this first equation right here, and we are going to take this expression and replace this y. So let me explain that logic. So the work that I just did here, this tells me that the letter y, the variable y, is equal to the expression 7 minus 2x. So the logic of the substitution method says, well, if this y can be written as 7 minus 2x, why can't this y be written as 7 minus 2x? And it can. We can absolutely take this y from the first equation and write it as 7 minus 2x, because this equation right here tells me I can. So I'm going to take this first, so the 5x minus 3y, but I'm no longer going to use a y. I'm going to use the expression 7 minus 2x, put it in parentheses, because this expression tells me that any y can be replaced with the expression 7 minus 2x. And then I finish off my equation, equals 23. Okay, so then I do whatever I need to do to solve this equation for x. So first I'm going to have to distribute this negative 3. So I have a 5x, nothing's happening there. Negative 3 times 7 is a negative 21. And then I have negative 3 times negative 2x, which gives me a positive 6x. And then that equals 23. So over on the left-hand side, remember before you start moving things back and forth, you always want to make sure that one of the sides is simplified. The left-hand side isn't simplified yet because I have a 5x and a 6x that need to be combined. And a positive 5x and a positive 6x give me a positive 11x. Okay, so now each individual side is simplified. So now I can go ahead and add the 21 to both sides. Okay, so they'll cancel from the left-hand side. Let's rewrite up here. So now all I have is the 11x on the left, and then on the right, when I add 23 plus 21, I get 44. And finally, last step, to get the x by itself, I will divide both sides by 11. So on the left-hand side, the 11 over 11 is just 1, so I technically have a 1x equals, and 44 divided by 11 is 4. So that is half of my answer. And only half of my answer. So step 3, remember we still have one more step up above, is we are going to substitute the first variable to solve for the second variable. So substitute the first variable. So we just got a value for x, so we're going to substitute it in to solve for the other variable. Okay, so I'm going to take this x equals 4, and I'm going to plug it in right here for x. So now I have y equals 7 minus 2, and then I'm going to replace the x with a 4. So all I'm doing is I'm taking this expression right here, and I'm replacing this x with the value x equals 4. So I have 7 minus 2 times 4 is 8. 7 minus 8 gives me a negative 1. So my y value is negative 1. Make sure, because remember what we were talking about with the previous set of notes, these are two different lines. What we're really looking for is the one point where the lines intersect each other. So you always want to write it as an ordered pair. So the x coordinate is 4, the y coordinate is negative 1. That is how your final answer should be written, as an ordered pair. Always written as an ordered pair. Okay, so flip, and we've got a couple more of these. So we can go through this a little bit more quickly now that we know what we're doing. So the first step is to solve for one of the variables. So this first equation has an x by itself, so we can solve for that value of x. What we're going to do is we're going to add 7y to both sides to get x by itself. So that equation becomes x equals 11 plus 7y. That's your first step, is to solve for one of the variables. Second step is to take that expression that we got and sub it into the other equation. So in the first equation, I can take this x right here and replace it with the expression 11 plus 7y. So 5, but then instead of x, I'm going to replace it with an 11 plus 7y, and then continue the rest of that second equation, plus 4y equals a negative 23. So just like what I did on front, the next thing to do is solve for y. So first I need to distribute this 5. So 5 times 11 is 55. 5 times 7y is 35y. And then I have that plus 4y on the outside equals negative 23. All right, so next, the same next step as we had on the front, make sure that each side is simplified. I still have some like terms I can combine. So I've got 55, I'm not touching that yet. When I combine the 35y and the 4y, I just add the 35 and the 4, and I get a 39y. I can't combine these two because they aren't like terms. And that equals a negative 23, so now I can start moving things around from side to side. So to get the y by itself, I'm going to subtract 55 from both sides. So they cancel here. I get just my 39y on the left-hand side, and then on the right-hand side I will have a negative 78. All right, so just about done. Let's transfer this up here. So I have a 39y equals a negative 78. So of course, to get the y by itself, we divide both sides by 39. And as it turns out, negative 78 divided by 39 just comes out to be a nice even negative 2. So again, that's the y value. The third and final step is to sub that y value back into this equation to solve for x. We know that x equals 11 plus 7 times y. Now we know what y is, so we can sub it in. So we know the x value is going to be 11 plus 7 times y, but like I said, now we know the y is negative 2. So this is 11 plus 7 times negative 2 is a negative 14. And when I combine those up, I get a -3. So there's my x value, there's my y value. Remember when I combine up as an ordered pair that there is an actual order we need to follow. The x value goes first, then the y value. So that is my answer, again, using the substitution method. So one more time, I'm going to use the substitution method on this one. Hopefully we get the hang of it by now. We're going to solve for this value of y right here. This one requires a little bit more work. Let's actually take this, let's multiply both sides of the equation by a negative. So when I multiply the left-hand side by a -1, the 6x becomes positive, the y becomes positive, and when I multiply the right-hand side by a -1, the 27 becomes negative. That'll make things a little easier because now not only is the y by itself, but it's positive. So let's transfer this over here. So 6x plus y equals a -27. So just like the first step I took in all of these other examples, I'm going to move the 6x over so I can get y by itself. And so this is going to become y equals -27 minus 6x. So that is my first step, to solve one of the equations for one of the variables. Second step, I'm going to plug this expression into the other equation for y. So this y right here is going to get replaced with the expression -27 minus 6x. So let's do that. So 3x and then plus 8y, but instead of y, I'm going to plug in a -27 minus 6x and then finish off the equation equals 9. So it looks just like this equation right here, except the y is replaced by this expression, which I wrote down right here for y. So same next step as the last two. I'm going to distribute the 8. So 8 times a -27 is what? -160. Hold on, just to be sure. 8 times -216. So minus 216, and then 8 times -6x is a -48x equals 9. So again, we've got some like terms that we can combine. We've got a positive 3x and a -48x. That combines to give me a -45x minus 216 equals 9. So in my attempt to get the x's by itself, I can add the 216 to both sides. So 216's cancel. Let's move ourselves up here. I still have the -45x on the left equals, and then I have 9 plus 216, which gives me 225. Any of these calculations that I'm doing, you can of course plug these values into your calculator. Like dividing both sides by a -45, we might not know how to do that in our heads, and so if you want to divide by a -45 in your calculator, you are of course more than welcome to. So for the x value, we end up with a -5. That's the second step. Third step, as always, is to plug this value of x into this equation right here and solve for y. So y equals -27 minus 6x, but the x is now a -5. So finally, I can solve for my second variable, y. So -27, and then a -6 times a -5, careful with that, ends up being a positive 30. So -27 and a positive 30 gives me a positive 3 for y, so I combine it up as an ordered pair. First my x term, then my y term, and that is my answer. All right, so that is the substitution method. Like I said, I think it's probably familiar. We are going to do the same thing with the elimination method. I'm going to write down the steps, and then we're going to do the same thing right here. So the elimination method, what we're trying to do with this method is we are literally trying to eliminate one of the variables in the equation. So they're all perfectly stacked on top of each other like this. We've got x's on top of x's, y's, and then constants. We are trying to wipe out one of the variables. So first, you need to multiply one or both equations by a constant. Let's say by a number, to result in opposite terms. So now this first step is probably something that you'll have to do depending on what equation we're working with. If we move down to example 5, what we mean by opposite terms. See how this first equation has a negative 3y and this second equation has a positive 3y? Those are opposite terms. They're almost identical, except one is positive and one is negative. So this first step is actually unnecessary in this version of the elimination method because we already have opposite terms. We have a negative 3y and a positive 3y. Let's say, for instance, that we wanted to get the x's to be opposite. Here we have a positive 4x, so we could multiply this equation by a negative 2 to make this a negative 4x, and then those would be opposite. But that would be a waste of time because the y's are already opposite. Step 2, add the equations, which eliminates one variable. And then we are going to solve. So then solve the equation. All right, so third step here. Actually, let's move down right here and do that second step. So add the equations, eliminating one variable. So we're going to combine these up. So what I mean by add is literally adding, like these two terms together, then we write it down here, add these two terms together, etc. So we are going to add the 4x and the 2x, and because they're like terms, I can just add them right up. So 4x plus 2x gives me a 6x. So I write that there. A negative 3y and a positive 3y. Those two, when I add them together, I get 0. So that's what the second step is saying. It eliminates one variable to add these two equations together. And then equals, then on the right-hand side, when I add the negative 22 and the positive 16, what I get is a negative 6. Okay, so that's the second step. It says then solve. So what we're trying to do is then solve for the x. So there's really just one teeny little thing to do, and that's to divide both sides by 6. So on the left-hand side, the 6's cancel. I'm left with technically a 1 in front of the x, but I don't ever write it. Negative 6 divided by positive 6 leaves me with a negative 1, so that is one of my answers. And then the third step is actually the very same as it was in the substitution method. So substitute to solve for the other variable. Okay, so then we take this x, you can plug it into either one of these equations. Now in these problems, the substitution step was super easy because the y was already solved for. In these ones, when I plug in the negative 1, I mean you can plug into the first one, second one, doesn't matter. The ones in the second one are slightly smaller numbers, so we might as well do that. So we plug in, so 2, but instead of x, we plug in a negative 1, and then plus 3y equals 16. So like I said, this third step is going to be a little more complicated than it was in the substitution method, but I think the first step is easier, so it kind of balances out. So 2 times negative 1, I get a negative 2, plus 3y equals 16. Then to get the y by itself, I'm going to add 2 to both sides. So I have the 3y left over on the left equals, and then I have 18 on the right-hand side. So divide both sides by 3. These 3's will cancel, and I have y equals 6. All right, so two values here. So I've got a negative 1, comma, 6. Okay, next one. We're going to do the same thing. So step 1, multiply one or both equations by a number to result in opposite terms. So here, the y's are the same term. So in order to get them to be opposite terms, what I do is I'd multiply both sides, both sides of the equation by a negative. So multiply both sides by a negative 1. That's what we mean by that first step. So let's rewrite these. So the 6x minus 5y equals negative 8. There were no steps necessary here to simplify anything up. And then here I'm going to multiply by a negative 1. So I have a negative 4x, and then multiply this by a negative 1, so I get a positive 5y equals, and then negative 1 times negative 12 is a positive 12. All right, so now I can jump to my second step where I add the equations. So add these up, positive 6x and a negative 4x is a positive 2x. These will cancel, that's exactly what I was going for, and then equals negative 8 and positive 12 gives me a positive 4. All right, so to get the x by itself, I just divide both sides by 2, and I end up with x equals 2. So that's half my answer. Then, like I said, I need to sub this x back in into one of these equations to solve for y. So doesn't matter which one, we might as well go for the first one this time. So 6 times x, replace the x with a 2, minus 5y equals a negative 8. And so we just simplify up, just like we did with the last one. So 6 times 2 is 12, minus 5y equals a negative 8. So to get the 5y by itself, I'm going to subtract 12 from both sides. These will cancel. I have a negative 5y. Be sure you keep that negative attached. It doesn't just disappear. And then a negative 8 and a negative 12 gives me a negative 20. Divide both sides by a negative 5. These will cancel, and my y value is a positive 4 because I've got a negative divided by a negative. So again, write my answer in an ordered pair. First the 2 for x, and then the 4 for y, and that is where those two equations intersect each other. All right, so one more here. So now these ones are already nicely set up for us too, because the first step is to multiply to get opposite terms. These ones already have opposite terms. So my first step, I'm jump right to the second step where I add the equations together. And so when I add them, the 2x's will cancel. When I add the y's, I have a negative 9y and a positive 6y. So that leaves me with a negative 3y equals, and then when I add these together, I get 6, positive 34 and negative 28. So then I divide both sides by a negative 3 to get the y by itself. So I get y equals, this ends up being a negative 2. There's my y value. And then again, plug the y value in. We could go into the first equation or the second. Like I said, it does not matter. As long as you're doing it correctly, you'll get the same answer either way. So I plug in the y, so I have the 2x, and then minus 9 times my value of y, which is a negative 2, equals 34. So simplify the left-hand side, I get a 2x. Negative 9 times negative 2 is a positive 18. And then I just have a two-step equation to get x by itself. So first I subtract the 18 from both sides. So they cancel from the left. I have just a 2x equals, and then 34 minus 18 is 16. So last step, I divide both sides by 2 to get the x by itself, and I end up with x equals 8. So now remember, when you write your ordered pair, the x value goes first, and then the y value. There actually is an appropriate order. That's why they're called ordered pairs. All right, and then our last equation here. Solve the system of equations. What we are looking for here, we can solve them in a number of different ways. Elimination starts off a little bit easier. So for elimination, let's take the first equation. We want to get opposite terms, so we can go with the x, we can go with the y, it doesn't matter. So with the x's, if this is a positive 6x, we want this to be a negative 6x. So we multiply both sides of the equation by a negative 3. And so let's rewrite that first equation. So distribute the negative 3, I get a negative 6x, a negative 9y equals a negative 15. And then when I line the second equation up right underneath it, so I just finished my first step, my second step is to add everything together. So when I add the x's together, they end up canceling. When I add the y's together, they end up canceling. So all I have on the left-hand side is 0. When I add the right-hand side, they end up canceling too. So I get 0 equals 0. So a quick thing to explain here. Let's say that all your variables cancel, which obviously that just happened. If you get 0 equals 0, that's a true statement. What that means is that the lines were actually the exact same line. And if that's the case, remember from the previous lesson, we get infinite solutions. Let's say we ended up with like 0 equals 2, which is obviously something that's false. If we end up with something that's false, the answer is no solution. So our options, we could either have exactly one solution, which are these two options. You could have no solution or infinitely many solutions. Infinitely many was because we ended up with a true statement here. That means the equations are actually exactly the same equation, the same line. No solution means the lines are parallel. You would know that this would be your answer if you ended up with a false statement at the end like this. Okay, and then you've got this in your notes, just a nice little summary, and hopefully that will help you out.